Hi, I'm Vishnu Priya. Today's session is demand paging. Demanding paging mechanism is paging system with swapping where processes stored in the secondary memory and pages are loaded only on demand, not in advance. When a contest switch occurs, the OS never copy any of the old programs pages from the disk or any of the new programs pages into the main memory. It will start executing the new program after loading the first page and fetches the programs page which are referenced. During the program execution, if the program references a page that may not be available in the main memory because it was swapped, then the processor considers it as an invalid memory reference because the page fault and transfers send control back from the program to the OS, which demands to store page back into the memory. Take an example for this. Let's assume an OS requires 300 MB of memory to store all the running programs. However, there is currently only 50 MB of data is there available as a physical storage on the RAM. Then the OS set up 250 MB of virtual memory and use a program called Virtual Memory Manager to manage the 250 MB. In this case, Virtual Memory Manager will create a file on the hard disk that is 250 MB in size to store extra memory that is required. The OS will now proceed to address memory as it considers 300 MB of real memory stored in the RAM. Even if only 50 MB space is available on the RAM. It is the job of the virtual memory manager to manage 300 MB memory even if it just have only 50 MB on the RAM. Advantages of demand paging are it's only loads pages that are demanded by the executing process. Another advantage is there is more space in main memory, more processes can be loaded, reducing the context switching time which utilizes large amounts of resources. Another advantage is less loading latency occurs at program startup as less information is accessed from second storage and less information is brought into main memory. And another advantage is main memory is expensive as compared to second memory. This technique helps significantly reduce the bill of material cost in smartphones. For example, Symbian OS had this feature. Then see what are the disadvantages for demand pacing using virtual memory manager or individual programs face extra latency when they access a page for the first time. Low cost but low power embedded systems may not have a memory management unit that it supports page replacement. This is the disadvantage. And another disadvantage is memory management with page replacement algorithms becomes significantly more complex. Possible security risks, including vulnerability to timing attacks, trashing, which may occur due to repeated page faults. We have new words which are involved in this session or page replacement and trashing. Page replacement and trashing are involved in virtual memory manager techniques to implement the speed of the memory and clear the hard disk space. Now let's to know what is page replacement. Page replacement happens if there is no free frame to allocate the memory. Here comes page replacement. Find some page in memory that is not that used and swap it out. A free frame was just created. Same page may be brought into memory several times over the life of a process. Use a dirty bit to reduce overhead of page transfers. Only modified pages need to be written to disk. Unmodified pages can be discarded. Page replacement completes the separation between logical memory and physical memory. Large virtual memory can be provided on a smaller physical memory using place replacement algorithm. What are the place replacement algorithms are? There are mainly three types of place replacement techniques. They are FIFO, optimal algorithm, LRU page replacement. FIFO page replacement means first in first out technique using the page replacement, and optimal page replacement algorithm is selects page for a replacement for which the time to next reference is the longest. Then another page replacement is LRU page replacement. LRU is least recently used page. This method helps OS to find page usage over a short period of time. This algorithm should be implemented by associating a counter within an event page.